Welcome everyone to our first SVG Europe audio event of 2024, IP Audio Forum, Discipline and Culture. I'm Heather McLean, editor at SVG Europe and head of SVG Europe Audio. So thank you for coming. It's great to see so many of you here. Today, we're going to be discussing audio over IP in two key areas: tracking the transition of IP audio topologies in live production, and IP infrastructure and next generation audio. Our speakers today are Matt Thomas, Warner Brothers Discovery Senior Sound Manager, who stepped in at the last minute yesterday to join us, so thank you for that, Matt. Chris Goddard, Broadcast Systems Engineer. Pete Walker, Calrec Senior Product Manager. Tom Knowles, Solid State Logic Director of Product Marketing Management. James Cowdery, Dolby Labs Senior Staff Architect, and also agreeing to join us just yesterday, Chris Scheck, Lawo's Head of Marketing, and thank you very much to Lawo, our title sponsor for today's event. We're also very happy to have our chair, Roger Charlesworth, back in the saddle again. So we're going to kick off with first of all with our panel, then we'll segue into a presentation titled IP Powering Next Generation Audio, Problems and Solutions from Dolby's James, which we'll also have time to discuss. Don't forget to post your questions for our panelists in the chat at the bottom of your screen. We shall answer those as we go along. Everyone's going to keep an eye on those for you. So without further ado, over to you, Roger.
Hey, thanks, Heather, and thanks everybody for joining this afternoon. It's really great to see everybody. This is such an interesting subject to me because I think this sort of transition to IP infrastructure has huge implications for audio. Suddenly, we can do things much more easily in terms of sharing resources, whether that's console cores or stage boxes on the studio floor. We also, on the plant side, are able to move more channels of audio. We're able to move metadata, and we're able to adapt as we go along. And this has huge implications for implementing next generation audio when we're starting to look at accessibility, dialogue enhancement, alternate commentary, things that we've wanted to do. Suddenly, IP audio infrastructure, IP plant infrastructure allows us to build those workflows efficiently. And as Heather mentioned, James is going to kind of talk us into that a little bit later. In the meantime, I just want to talk about from a regular old audio perspective, what the implications are of 2110 and go into a little bit of the different variations we're seeing. I'm kind of curious about what the topologies of these infrastructures. Are they all 2110? We still see a lot of local routing that's Dante or regular AES67. What does that all kind of look like? And try to understand this sort of strategically. So I want to break this first discussion kind of into two areas, beginning by talking about plant infrastructure and then sort of break down the local routing problem and various solutions. So I guess the first question is on the plant side, and I guess, Peter, you are involved in supplying equipment for a lot of projects. On the plant side, is 2110 going to be the standard if people are building something new? Is it going to be the standard going forward? And as people update their facilities, are they automatically adopting 2110 infrastructures?
Yeah, so absolutely, yeah. I mean, at Calrec, we've jumped in with both feet. So basically, all our products are native 2110. So whether people want it or not, they're getting that. They might only be interested in buying an audio mixer. They might not really have an interest in IP, but it's the standard offering is it's a 2110 based system. So we make that easy on a small system. You know, if you're just buying an audio mixer with a few stage boxes, we can pre-configure that so it works out with the box. You can use it in a very traditional way within a legacy kind of environment. And over the last few years, we've seen a lot of people doing that as a sort of dip a toe in the water, migrate, get more comfortable with it. But now we're seeing, and alongside that, we've seen that sort of the big players who actually want IP and want that to be a fundamental part of their infrastructure. And now what we're actually starting to see is the smaller customers with the smaller budget and some of the emerging markets. They're increasingly wanting it to be the IP to be the heart of the facility. So it works both ways really. You get in the 2110. You don't necessarily need to know that it's 2110 or care that it's 2110 because our UIs and our discovery that we put on top of it make it intuitive and easy and, like I said, plug and play. But it gives you the flexibility to expand and incorporate into a full, take advantage of the full 2110 infrastructure, which ultimately means fewer stage boxes, fewer cables, just lots of flexibility.
Yeah. Well, Chris, you guys, I don't even have to ask you this. You guys are actively involved in integrating 2110 systems, but please talk to this issue.
Yeah, I was just going to say, like, we come from it, well, we come at it from the other end. Like, we decided a long time ago that the world, especially the broadcast world, was waiting for an open standard and for a comprehensive standard. And so everything we've built and installed and deployed for, gosh, almost 10 years now has been SD2110 compliant or else Ravenna compliant. And we see that customers really like the idea. Like the IP revolution has yet to happen. There are still lots of facilities where there is no IP whatsoever. But there are also big projects that we did just recently, like, for example, the CBC Radio Canada installation, and lots of them before that, like as far back as 2017, NEP in Australia was looking for a way to do remote production via a cable. So that became IP, like it was probably one of our first lighthouse projects, and audio has always been part of that.
Yeah. Well, in terms of audio, what is it that this sort of that is inherently different about this sort of 2110 infrastructures, and how do they advantage audio?
Well, there are, sorry.
Go ahead.
Well, first of all, like what we still need and what you will need for the foreseeable future probably is gateways. Like you have to connect your probably analog microphones to a gateway, which then translates the digital audio into a stream. And once you're on the SD2110 layer, you can pretty much do anything to your audio. You can send it where you want. You can, as is being done increasingly also, like you can have on-field cameras, for example, that also pick up the audio, but you can de-embed the audio from that and add a different audio track too. So essentially it means that you're incredibly flexible.
Well, I guess, part of that is sort of being able to have larger audio streams. And I guess you can have an audio stream up to 64 channels. And I think as we look at adding on the program side, as we look at adding 514 Atmos or additional commentaries, alternate music, with 16 channels in SDI has always been a limitation. And though that spec was expanded to 32 channels, nobody ever implemented it. And maybe the audio guys forgot to ask for it, so we just assumed we couldn't have it. But this sort of flexibility has got to be a big thing. And Matt, we were talking about this the other day, but you kind of did something sort of unbelievable in sort of taking the BT Sport in-house into the Discovery facility. That facility was built as sort of a stereo facility, and yet you were able to sort of adapt it to 514. How the heck did you pull that off?
Well, that's one of the key benefits
of IP is the flexibility and the fact that we were able to take a whole TV facility and just absorb it. The core part of the infrastructure just absorbed it. Yes, a lot more end devices, a lot more cores, but a lot more audio cores. But the key here is that the core IP fabric just absorbed it, and that's what I find incredible about it. Is the scalability.
So this sort of becomes a configuration issue, and as you say, more edge devices that are more channels, but but the fabric just kind of marched on. Yeah, go ahead.
That's it. And we were a 2-channel facility across the whole of Europe, and then we absorbed the BT Sport, turned it into TNT Sports, and suddenly, and that was a 5.1 Atmos facility, and we were able to. Well, we had to do a lot of configuration changes, and the control system had to be rewritten in certain areas. But it was a project that happened very quickly, within the space of 12 months.
Wow, that's amazing. Well, and it's an important point too. It's sort of like that facility was designed to be a stereo facility. Okay, fine, but these things are inherently changeable. And that's the thing. We sort of just think, oh, we're stuck with 16 channels because that's the way it used to be in SDI. And I think what would be a shame is if we don't sort of strategically plan if we want to support more advanced audio programs, that we don't sort of plan around more channel counts in program. What are the sort of problems though that you run into with in a 2110 world where it's a multicast system? There isn't anything really, everything is everywhere. What problems do you run into with sort of channel counts between devices? Anyone want to take that? Pete, I mean, don't you have some things that are, or Chris, anybody?
Well, first of all, it doesn't have to be multicast. Like you can work both in multicast and unicast, so you don't have to send all the data everywhere.
Yeah, but I'm just talking about sort of channel count sort of incompatibilities, and how much are those a problem, and how do you address them?
Well, from our perspective, because we're sort of typically in the center of the workflow. We find it incumbent on ourselves to sort of be as versatile and as flexible as possible so that we can overcome limitations of other devices. So we're trying to avoid, often you have to come down to the lowest common denominator. Certain devices might be limited in the number of streams or the format of the streams. It's not just necessarily the number of channels, it might be the packet times. Packet time actually is an interesting point. 2110, everybody's using the 125 microsecond packet time, but there's some older devices or devices that might come from a more audio background, less video focus, that might be limited on 1 millisecond packet times. So we have to, our approach is to be able to handle streams of different channel counts, different packet times, different codecs, all at the same time simultaneously, and we try and adapt to changes. So if we can set up a receiver of X channels, it doesn't really matter what stream we're receiving. We will take what the channel count that it's got. If it's fewer channels than we've got, it doesn't matter, and we can create a stream from 1 to 80 channels. So we try not to be the lowest common denominator and just try to be flexible. But for the sake of sanity, people often want to stick to a given format, and they will work to the lowest common denominator of whatever is the sort of the weakest chain in the link, if you like.
Well, so the console ends up being, though, sort of the console ends up being kind of a router in itself. Take something, a stream that's different from another stream, and you sort of you're cross-docking them in the console. But when we're going from device to device, then it becomes sort of, if it's a playout server that's not necessarily going through a console, then it needs to, there needs to be some sort of agreement in like what a program is in terms of channel count.
Yeah, but they can switch their packet time on us or their channel counts on us, and it doesn't really affect us receiving from that device.
One of our,
Matt?
Sorry. No, go on.
just saying, one of
Go
our
on, Matt.
one of our biggest issues is audio consoles generally are quite flexible with regards to receivers and senders and numbers and channels. But we've got an example at the moment that we're having. It's not issues, but it's slightly how can I put it? Frustrating. Yeah, challenging. And it's EVS. EVS only do 16 channel senders and receivers.
Right.
So if we want to not use a whole 16 receiver on a desk because of DSP count, then we have to split it into 2 channels. Then we have to take it through another device, adds latency, splits it into 2 channel senders. And these are all the things that you come up against that you don't realize until you're actually in the thick of it and you're trying to build these kind of systems. And then you're adding latency into your audio. And then if you turn it from a 16 channel into 8 2-channel flows, and then if you're going to go and you go the other way around back into EVS, that's 8 milliseconds in total. And at the moment, we can't get around it. So we are 8 milliseconds audio delay in certain scenarios at the moment.
And I guess my experience of that is that it becomes that people choose channel to stream ratios for their planned routing, and they stick with that for most of the time, often so the control system seems fairly sensible and uniform across the board. And they either break out to audio routers to do audio routing as a little small TDM box, or they hand those signals back to the audio console, and the audio console becomes the audio router to manage that. So it's almost like you've got these 2110 stream pipes that are great and flexible because they're a bit like having MADI or SDI pipes that can grow and contract on the hardware and the fiber cables you've put down there, but you're using it as pipes of streams. You're not necessarily using it as an audio router on the plant side. And it's handed to an audio router or back to the console to be an audio router. That's our experience of most 2010 anyway.
Yeah, well, that's an interesting question too. Is sort of like normally we think of, and this is the question I want to get into too, is normally we think of in SDI world, SDI is just on the plant. It's things that have a fixed number of channels they have programmed. We don't use SDI. Well, we do sometime in remote production. We don't use it to ship a contribution audio around. We only use it for program audio. So if we're looking at trying to solve this problem, is there some advantage in saying, hey, listen, everything needs to be X number of channels? If I'm going forward, everything that's program needs to be 32 channels or 64 channels or whatever, just so everything that's carrying program can talk to something else that's program without having to reroute it. Is it reasonable to say you're going to standardize? And how do you, Matt, how do you even deal with this now? You sort of have the facility sort of partitioned, it seems like, of parts of it support 5.1 or 5.14 and parts of it are still stereo, right?
Yeah. There's lots of ring fencing around bits of equipment and resources. We're still finding our feet. And I think there's a long way to go. We're on air, which is good, but I think we've still got a long way.
Sounds great. Looks great.
We've got a long way to go, though. I think, we've tried to be as efficient as possible, but there is a lot of conversion going on. When I talk about conversion, I don't mean different audio formats. I just mean channel conversion from 2-channel senders to 16 backwards and forwards. But utopia would be if we went back to, doesn't have to be 16 traditional baseband SDI workflows, but if we could everybody could move forward and agree on a standard where it's going to be just a flat 32 audios. That's what you get, and then you're limiting yourself in your flexibility, but at the same time, it's simplifying what, you know, when during the planning stages, it's simplifying how you're actually going to go about actually achieving what you need to achieve.
Well, and you guys are pumping around 4K HDR video, for Christ's sakes. You know, it's like a couple extra channels of audio really in the scheme of things. It's not a big deal, I wouldn't think.
Not for payload. If you look at it in that, and coming at it from that angle, it is more the management of it, and the fact that at the moment, all manufacturers are all taking it upon themselves to decide what they should be sending and receiving audio flows wise, numbers wise. So, and I say the audio desk side of things and the core side of things, they're the most flexible parts of it. And like what Tom was saying, you know, perhaps we should put more of the onus on the cores to do more of the conversions and all that sort of stuff, from 2-channel senders to more multi-channel senders.
Well,
let me see.
That's what, you know, that's what I think effectively happens a lot of the time. But I want to return to this question in a minute, but Chris is sort of, as Chris Goddard is sort of an integrator, and in terms of planning, you sort of connect everything to everything, and you're not quite as worried about, oh, this wire needs to go to this device. So sort of on the physical layer, in a way, I would think the engineering would be simpler. Is that? Don't never say it's easier.
Sorry?
Never say it's easier. I'm sorry.
No, never say it is. No, I've been approached too many times by people saying, can you just, or simply, and I know I'm just about to be presented with the worst thing I've ever been asked to do, taking way more time than anybody has ever expected. Fundamentally, it is as simple as, well, all the devices are edge devices. There's a switch in the middle. Just build it. But the requirements for the system are never that straightforward, and I'm still putting systems together that have islands of different IP. You know, we talk about IP. I know we're talking about 2110 specifically here, but IP just seems to be spoken about as if it's all-encompassing. That's it. It's IP. It's great. Monitoring. You mentioned EVSs as a particular issue. You can reconfigure an EVS, and the number of sources, destinations changes depending on the requirement for the production. How does your control system manage that? How does an operator monitor it? If all of the audio is in a flow of 16 channels, how do you actually get to that, to the operator to just listen to a stereo in their headset? I built systems where the right monitoring equipment wasn't available that was 2110 compatible, but we were building a 2110 system, so it had to be in Dante. So you're back through the console again to turn it into Dante to get it across to your monitor. So there's lots of tie lines and bridging and gateways between different systems. Decisions to make. Does the comm system sit at its own network, or is it part of the media network? Is that really a sensible thing to do? I've done both, because the requirements of the customer is, no, we have to have it separate. We just don't want the complexity of having it all sitting in the same media network. Does your central media switch based on 40 gig QSFPs, 100 gig QSFPs? You know, the actual real connectivity into the equipment. How do you build that? Do you put top of rack switches in every rack, so you've got a common approach to scaling your build, or is it just tie lines in a rack back to a swing frame and you patch everything because it's cheaper to buy larger switches in a central location rather than lots of smaller switches? So there's lots to be thought about and decided upon when you're actually putting it together, as well as just the configuration that then runs across that network.
Well, you kind of hit on something that I do want to get to next too, which is this sort of local things, comms things. There's an awful lot of audio only stuff that has different requirements, and that may be sort of simple devices that, you know, do they have to have the capacity to listen to this huge amount of traffic and reject traffic? And monitor constant chatter of comms on the plant system, or do those things inherently belong in a audio only routing environment that is separate? And there are a couple of questions around this. We could start anywhere, but I think that's my first question. I guess there are pluses and minuses, but is it inherently, Chris Scheck, you're looking like, does it inherently make sense to sort of separate these audio only things, no matter how you're routing them, but or how they're speaking, but does it make sense to separate them out?
Well, yeah, I don't think so, because ST2110 actually separates every audio signal and every video signal into separate essences. So they're on the network, you can pick them. They don't have to be, as I said earlier, they don't have to be multicast. So you can send them from one point to another. And of course, the most sensible thing to do would be to work with a broadcast control system that allows you to choose what you want to listen to. And having everything on the same network also has the advantage that you can use such signals in different places. So why would you, if I understood you correctly, why would you want to create two separate
but 2110
networks?
has some limitations, and even I kind of thought that even in Lawo installations, the VSM doesn't go to the mic preamp level, that there's a translating protocol, I thought, but maybe I'm wrong about that.
Yeah, well, for that, we have a separate system, a management platform called Home. But
that's an example, is effectively Home is managing the mic preamps, not VSM in that environment. But let's take more extreme cases. And I kind of, in my experience, and Pete, you can talk about this, maybe I'm wrong, Tom, but in my experience at Chris Goddard, everywhere there's some Dante and there's some tasks that seem like maybe the A1 is doing, the A1's plugging in a belt pack or something like that. And that stuff is
yeah, I don't know if I understand where you're coming from. I'm not sure comms is the right right example here. In that comms is pervasive, if that's the right word. Comms is a major aspect of the system, and I think that does live on the main 2110 network. But where Dante really comes into its forte is more ad hoc connectivity. It puts the I view comms as a fundamental part of your production infrastructure. The Dante is given, Dante devices give some control to the audio crew. You don't need to run it past your truck engineers. You can spin it up as a separate network. You can test these things out at home. You can buy your own kit. There's low-cost equipment, low-cost switches. It's easy to plug and play. It gives them some flexibility. A good example of use of Dante is often commentary panels.
Well, that's right, yeah.
Yeah, where it doesn't need to be so widespread throughout the entire production, but it's a good way of having a small network to extend the audio room from within the truck to wider parts of the venue and whatnot. So Dante, we sell as many Dante cars now as we ever have done. The popularity is certainly not decreasing, but we still sell a lot of MADI as well for similar reasons. So although our backbone is 2110, you're buying it whether you want to use 2110 or not. It's in there. It's what it's running on. But people are still using lots of MADI, lots of Dante to add to that. And you might describe that as a gateway to a degree, but it doesn't feel like a gateway, because it's, we make it simple. We make the routing of getting an audio signal from an input to an output not feel like you're having to go through complicated configurations. And the word gateway in itself can be a little bit off-putting, I think, in some circumstances.
Well, I would imagine that almost every frame you sell has Dante. And when I look at, a remote truck or even studios that I see, there's sometimes multiple of these ad hoc networks. Somebody says, I'll plug something in, and somebody comes up with a little, lipstick Dante interface. Tom, tell us, you guys extensively use Dante, and uniquely, I suppose.
Yeah.
the console is the Dante router. So there's not a Dante controller. You actually use it to route internally the console. But how
Correct.
is, and I guess the model is like the console just deals with audio. You will separately have 2110 interfaces for the plant side, but everything that's local audio routing is Dante.
Yeah, I mean, we kind of, it's very similar to what Pete was saying, but a bit more kind of closer to the console, as you say. The console's audio router is the Dante network. It obviously does routing inside its own engine, but the engine is almost an endpoint. And when you make a route on the console in the software, it's using the Dante API and it's creating those streams and subscriptions on the Dante side. And then we can hand off to a 2110 network via a Dante card in DDM with 2110 enabled, or AS67 if that's the way it is, or a lot of people run that through other conversion devices because they already happen to have that. So we always can hand off to the plant, but use Dante as a router. And I think we kind of touched on it before when we're talking about channel capacity. Like something 2110 is great at is doing big chunks of audio, like multi-channel audio from one place to another and sending that all together. Yes, you can pick audio channels in and out of that stream, but what it doesn't do is even with NMOS, there's no stream creation. You have to build the stream at that transmitting endpoint. So if you boil it down to mono audio routing, there's a level of complexity with 2110 that is quite hard. And if you treat that like an audio router, all we really do is say that audio router is a Dante network. So we obviously see a lot of Dante devices because all our I/O is Dante, but we also then integrate with the small commentary units sat on the desk, the kind of Dante speakers or other Dante stage boxes. So it's kind of, it's the same scenario, but we're using Dante as the audio network for the console and handing off to the plant.
And in some cases,
just a comment on that, if I can, just to play devil's advocate, that you still have the same issue of the number of flows that you can achieve. So if you think about a Dante network as you can do the mono audio routing, if you route a mono channel from device A to device B and nothing else, it fills it with silence and you've still used up a whole flow, you're going to hit some limits eventually. But that's just as a comment.
It is a comment. And in the early days, Chris, I was really concerned about that. And honestly, the times that we hit that limit from a console routing point of view are so few that it kind of, I think it was an unfounded worry. I mean, we talked about doing automatic multicast creation, automatic multicast stream creation when we ended up with the same signal going to 4 or 5 places. It just wasn't required. It never hit that. So yes, it exists. But the channel to stream ratio of most of those devices, of all of those devices, is pretty high. The stream creation part of Dante is unique, and it kind of, the downside is it hides that from you. It doesn't tell you exactly where those streams are. But if you're an audio operator connecting signals around, that doesn't particularly matter for you, which is why 2110 is so good on an engineered plant network where you do really care about where those streams are.
Yeah. Interesting. And Pete, in some examples, you will have AS67 like amps that aren't necessarily part of the 2110 network too. It's not just Dante. It's also, there are sort of topologies where there's local audio routing around the console, whether it's A67 or Dante.
Yeah, so one of the things that did come as a bit of a surprise to me is how some people are deploying them. You know, flexibility is always key in broadcast. So we really try to not put up any barriers and be as flexible as possible. But one of the things I'm finding that is some people, our stage boxes are 2110 and they're NMOS capable, but people don't tend to want to use them in that way. They tend to want to connect the stage box as though it's a more traditional stage box using our discovery and our UI for connecting that. So that again puts it in the hands of the A1, the audio mixer. He's managing his mic sources, even if they're not in the same facility or city. they tend to want that to be an isolated, the stage box to mixing desk as a separate thing for them to manage by the audio operator. But from the core, from the DSP router, that's where it hits the NMOS and what they perceive to be the 2110 world. So in those cases, they might refer to us as a Calrec island or even an AES67 island. But that is kind of semantics, really. It just helps people break it down in their head. And at the end of the day, it's just about the workflows that they want to adopt. And you touched on multicast a while back as well, Roger. And one of the things I'm finding is that we're rapidly going down the SDN route now, the full layer 3, and effectively these guys are creating unicast point. It might be multicast audio at the heart, but the way they're managing their SDN networks and their subnetting is they're effectively creating point-to-point connections and very tightly managing that routing. So when it gets onto the larger scale, if you're worried about bandwidth management for multicast, I think that's the way that we appear to be going.
And
well,
Pete, sorry,
go ahead, Tom.
Pete, does that kind of prevents any ad hoc connections? I mean, you can design for it, but it's pretty hard to design.
Yeah, absolutely, Tom. And I think that's where I was trying to go with that, is that sort of complements, that's where we have this perceived Calrec island. It doesn't quite fit within that layer 3 SDN thing, because they do kind of want that ad hoc thing on the side as well. So there is a combination of things going on.
So then does the console become the gateway to that? That's for something to be published on the larger network, the console has to then publish it. Somebody says, I want to be able to pick up this microphone in Bristol, then the console will have to push it out to the.
Yeah, if that's the way they choose to work, that's what they will do. And if you're coming at it from a traditional point of view, then who else needs access to that Calrec mic amp on that stage directly, other than the A1 that's giving it some processing before he's ready to pass it on to the next person in the chain. But yeah, it's horses for courses, really, different workflows.
Well, and I guess, but it's also like, I guess one thing is like, coming back to the Dante question, it seems like there are cheap and cheerful Dante devices that don't have the horsepower to live on larger networks, would never have the horsepower to live on larger networks.
I don't know about that necessarily. I think
most of them can. There are older ones that can't, but most of them can be put on a larger.
But I mean, is it likely that we will have, for the A1 example, I'm hot plugging something, just don't have a fixed IP, discovery sort of happens automatically. Isn't it likely that we will always have Dante devices hanging off the console?
Well, I think for today they serve dual purpose, and I think Tom spans both worlds, but it's like our experience is typically that more ad hoc, smaller networks. But like Tom says, the Dante modules, the same hardware is capable of acting in AES67 2110 mode as well.
Sure.
At that point, you're introducing the same level of complexity or the same challenges that you've got with any 2110. You're not necessarily getting the benefit of Dante at that point, other than it's the same physical piece of hardware. So you can switch it up depending on what suits your needs.
And isn't that the point? Designed for application. Yeah. Whereas 2110 is engineered, and someone has to create a stream for that signal to go anywhere. Dante is not that. You plug it in, it presents as channels via the Dante API, and you can connect them, and it creates that stream automatically. I guess, come back to your question, Roger, could that all happen in a 2110 environment? My opinion here is that you would need a common stream creation API for every 2110 device. That's probably quite hard to achieve, but we'll wait and see.
Well, I think there's a bit.
Sorry,
go on, Chris.
Yeah, well, I beg to differ, because that's precisely what Lawo's home management system was designed for. Like, there you can connect devices, they will present themselves, you can admit them or you can reject them. So it is already possible in ST2110, and it's intuitive.
Well,
It's
I wouldn't
not-
call it. I wouldn't call that. I mean, I wouldn't call that 2110 though. I think your point is you have an AES67 network of devices that are around the console, and I think that's the argument, that there's always going to be sort of local routing on the console that you don't necessarily want to manage from the plant router. But what about, and you touched on this a second ago. Oh, stop, leave me alone. Sorry, I'm back. Mute your phone. What about, you know, we kind of are virtualizing over distance. Pete, you mentioned it. Chris, Scheck, you mentioned it. Is 2110 adapting to be able to manage these wide area?
So yeah, we're
networks?
Yeah, it is, yeah, and I think we might move on as well into talking about other codecs and stuff. But if you've got the money, if you've got a global network, which we are seeing now, you know, the big, I think esports have pioneered this a lot, and now the more traditional sports outside broadcasters are rapidly catching up with them. But yeah, they've got their global reach networks that they can comfortably pass 2110 over. So they have a true distributed production sort of model. Doesn't really matter, you know, whether you can have stage boxes on the other side of the planet, you can have different operators in different countries. That 2110 does work at that level, but you need there's a certain budget that goes with that in having that network and that determinism, that latency, the jitter management, and the layer 3 routing. But it's increasingly happening. But then for the customers that aren't quite in that league, that aren't quite as global in their outlook, they will use codecs to tunnel 2110 basically.
Yeah. Well, and we're kind of like, as we are doing stuff on the public internet or doing stuff in the cloud, we're kind of using a lot of things on a sort of off-the-shelf NDI or SRT to get up to the cloud or to acquire signals. Where do those kind of fit into? Does this fit into this whole narrative? And what, you know, where is that going? And where do we get to with routing solutions, audio routing solutions in the cloud? You know?
Yeah, well, I think that is where the 2110 does hit a barrier. So getting things between facilities around the world, if you've got the connectivity is one thing. When it comes to cloud and software processing and on COTS sort of PCs essentially, and the sync management, then an increased latency, that's where 2110 doesn't necessarily fit today. I'm not sure whether it ever will. It's certainly possible if we put the effort in, but then there's alternatives that might be easier and more affordable. I think Tom is likely to be able to speak more confidently about this area than I can.
Yeah, I mean it's a challenge. Like 2110 is multicast. AES67 has unicast options, but there is 2110 multicast transport. You cannot use that between instances on public cloud. It doesn't work between instances on AWS. You can use it in a single instance. There are ways of getting it from the ground to the cloud via gateways up and down, but between instances doesn't currently work, which is one part of the barrier. But also, as Pete says, the software element to it, which people are doing software 2110. Most of our cloud kind of POCs and people putting things on air have involved SRT on a contribution level, so from the venue over public internet up to the cloud. A lot of NDI, which has its uses, but it also gets a bit messy again from an audio point of view, because different streams are not synchronous. So you have to be very careful about where you put channels in each NDI stream. And it's a bit like using SDI or 2110 streams, in that it's not really mono audio routing. It's, again, here's a stream of audio together, pack it from one place to the other. And again, that's where we've used mostly Dante Connect, which is essentially Dante running as pure Dante streams, so full PCM audio in AWS and cloud data centers, using the fact that it's unicast by default and using PTP v2 unicast to manage the clocking. So there's a mixture of all sorts of things, but it's the same. Again, it's like use the right technology or standard for the specific application at hand. There's no one size fits all. You kind of fit and feel what right streaming technology, IP technology fits the job and the network infrastructure you have. It's been our experience so far.
Chris, one more thought.
Yeah, well, at Lawo, we're trying to build a platform, a common platform for all users, be it audio or video. We released home apps last year. They are perfectly able to convert from and to SRT NDI. We also accept, of course, Dante. But well, maybe the wisest thing would be to remain within the SD2110 realm as long as you can. But once you have to either ingest NDI audio or SRT audio, obviously you need that conversion. But all that is part of the same platform I talked about of home, where you can leverage the strength of both software that can run in the cloud, that can run on a standard server, and pushing it to the console, which, by the way, and I think it's the case for everybody, the console is no longer a console. It's just a very sophisticated remote control that sends signals either to the cloud or else to a processing core. Which also has other advantages, by the way, like, well, you are probably aware of the remote audio control room that's being used in Germany to mix Dolby Atmos, which is 5.1.4. There's one guy sitting in one city not too far away from Frankfurt, mixing a football match that's going on in Munich. And yeah, well, so the audio that travels from the stadium where the processor sits, like the DSP processor, is only the audio engineer needs to hear. But what he does on the console actually is only sending instructions back to the core, so thereby eliminating unnecessary latency latencycy.
Right.
And well, the idea is customers just need to know what they want to do, and we need to find an answer to satisfy those requirements.
Well, certainly we're going to see more virtualized production, and we look at the trend of production hubbing, and one of the things, the sort of the superscalers like AWS end up being the connectivity partner for that. So how this stuff operates in the cloud, how we manage audio and how we manage video in the cloud starts to become an important part. Because if AWS is the transport partner, then it probably makes more sense to build the control room in AWS than to build it on the ground somewhere. But you know, we'll have to see. But listen, I think we're gonna jump over to James. I think with this discussion, I know there's a lot of other stuff we kind of we didn't get to, orchestration, all kinds of other stuff, but this is an audio discussion. So I think one of the things I want to take away is it sounds like, coming back to just the plant router question, it's like, how many channels of audio do we actually need? And when we're planning going forward, do audio people need to step up and say, hey, by the way, I need more than 16 channels of audio? And when we're talking to EVS and we're about to buy a stack of EVSs, do we need to say, hey, 16 channels worked 20 years ago, but it doesn't work now. So, James, do you want to talk to us a little bit about how IP infrastructure is impacting what we want to do? Oh, yeah. And, you know, we've talked about these things we want to do for a long time, and the next generation MPEG-H and Dolby AC4 codecs have been around for a while, but up to now, we really haven't built the infrastructure with the appropriate signaling and channel counts to support these features. So.
Okay. Well, thanks, Roger and Heather, for inviting me to talk, and hello to all my friends there in Europe and the rest of the world. If you hear funny noises in the background, I'm almost on top of a Santa Monica metro station here, so you might hear the odd weird beep. Let's get started. So I'm going to start with just kind of review of problems facing us in industry audio today, and just thinking about how the problems and these whole bunch of new technology is coming together at the same time. So that technology is addressing those issues. We're going to dig into some of the detail and some of the tools, specifically serial ADM, and have a look at some new tools which are just coming online, which are in development at the moment. And just conclude by focusing on solutions and how flexible technology can be kind of brought together, give us lots of choice, and give us choices not just for today, but for the future as well. Okay, so what are the audio problems? Well, a lot of these will be kind of familiar to you. The intelligibility problems. So looking back, it was 2017, there was a whole big thing in the British press around dramas and problems with programs, a lot of complaints. And just back in August this last year, New York Times ran an article about problems in intelligibility with streaming services. So this problem just doesn't seem to be going away. Obviously, you'll be familiar with the lack of choice of audio on services. There is some bright points seen on VOD services, things like dialogue enhancement, language replacement is being done, but it's obviously with streaming services, VOD, it's easier. It's not universal. And you'll notice these are all user problems. These are not industry problems. And I think we need, as we spend a lot of time, and quite rightly, thinking about the problems that we face in an industry, trying to do more with less, keep things running, make things work better. But we also need to reserve some time to think about how we can evolve the experience for those folks at home, not to kind of lose sight of that, even though I know with the pandemic, really a lot of that had to be put on pause. But that's kind of behind us. So, you know, I think now we've got an opportunity to start thinking more about how can we improve things for the user? How can we make the experience better? So next generation audio, immersive, personalized accessibility, that's all supposed to address these problems. Okay, so technology, a lot of this has been talked about. You're familiar with the acronyms. Well, perhaps -41, SMPTE 2110-41. You might think, oh, what's that? I haven't heard of that before. That is serialized ADM, which I'm going to talk about. It's a metadata. That's a way for metadata to be carried across SMPTE 2110 in a kind of native way, native IP way. That's in SMPTE Audio at the moment. That's going to be published later in the spring if all goes well. So keep an eye out for that. AC4 is now, it was conceived somewhere around 10 years ago, but just recently we had a couple of official launches here in Europe. Still talking with when talking with networks and rolling out set-top boxes and so on, the deployment of AC4 still going ahead. So NGA codec, that rollout of codecs in the market is still in progress, but a lot of progress has been made. Hence, you've got services launching now. So AI, because everybody's talking about AI, but run the risk of jumping on the bandwagon. There are a couple of technologies that are really interesting when thinking about next generation audio. So audio source separation, when thinking about separating dialogue from music and effects, this is interesting because if you think about technology transitions in the past where we've maybe gone from stereo to 5.1 or 5.1 to 5.1.4, the use of upmixers as a kind of bridge, a way to create new content from legacy content and help ease that transition, it's been really useful. Well, for M&E plus D, that's where you've got music and effects and dialogue are separated. That's difficult to do, but audio source separation provides a way, and it's rapidly maturing, reaching commerciality. So that's something to watch. Auto mixing, again, really interesting, especially when you think about metadata and separate audio elements, keeping everything separate, describing what the process of auto mixing and giving downstream folks to review what's being applied and back things out or edit things as needed. That gives a lot more flexibility than just applying a blind or automated mix and it not being able to undo it if needed. So thinking about the basic core technology elements for next generation audio, and that's again the immersive, personalized, accessible. We have three kind of swim lanes, the bottom three here, technology elements, but a lot of it is kind of dictated by the audio production format. So if you think you've got 5.1, that naturally has a partner with Dolby and AC3, and as you go to 5.1.4, that dictates new descriptions and it dictates a new consumer emission codec as well. And the same goes for next generation audio, where we now need to use M&E plus D for personalized and accessible use cases. That's a lot of channels. So we're talking about stressing out legacy infrastructure and channel counts. We need a description if we're going to change things around. Have more flexibility in our audio format. We need a description to tell people what they've got, and we need a modern NGA codec to get that to the consumer. So I'm going to focus on these middle two because they're interesting. I could spend a lot of time on AC4. I'm not going to do that today. So 2110, Roger talked about channel counts earlier, said blame the audio guys, of which I count myself as one, as not asking for it. Well, it was back in 2007. Yes, we need it now. We probably needed it a few years ago, but it's really just difficult to know. And I think now we're at the end of the cycle, so I think it's unlikely we're ever going to see those extra 16 channels. So we're stuck with the basic 16, basic SDI, I think, forever. That's my assumption. And that's really not good enough for NGA, because you think you've got M&E plus D, that's 10 channels, and a couple of dialogues, a legacy stereo. You're soon hitting up against the 16. So really, IP is empowering or enabling next generation audio by breaking through that 16 channel barrier. So the two big things with NGA that we kind of need, technology things, yeah, we need more channels, but we also need an audio description, because we've got this bunch of stuff. We don't know what it is. It's going to be very difficult to manage it. And that's the idea of ADM as a file-based format. And then serial ADM really is quite kind of simple from a technical perspective. It's just a way of sending a file repeatedly over a wire. But it's more important than that, because having that description of what you've got gives us the ability to step back a little bit from the audio and the details of what's in it. And I know I've been listening in and hearing all about this mono channel and routing here, and you just, wow, we're just stuck in the details. Well, is there an opportunity here with serial IDM, at least where it's used appropriate in the workflow for it to be used, to take advantage, leverage those descriptions and have the software do more for us and kind of take a step back?
So I want to stop you there for a second, James. So you're saying if there's an alternate commentary in French, you need to tell the ATEM or harmonic encoder that it's coming, and you need to label it in order for that to happen. Just even if it's something simple of just saying, this program has alternate commentary, this one doesn't, this is the language. Those sort of simple, just...
Yeah, I mean, let's take a simple case where you're doing a couple of languages and English and French, right? And English is on one, French is on two, right? And the description knows that. It goes to the encoder, and the encoder says, well, I want the English presentation, so I'm going to transmit over this service. And then someone clever person upstream swaps 1 and 2 over, right? The description changes, that flows downstream, everything jumps back into place, because you're telling the encoder, you're not telling it use 1, you're telling it use English. So that gets us away from numbers. That's the idea.
Right. Okay, sorry, go on.
Okay, so creation of serial ADM. So it's really simple. You take your ADM, which is that description of what you've got. You've got a track mapping, which is the mapping of those audio elements onto the tracks of your physical media. You combine that to create your serial ADM, that new XML. You compress it. You put it inside a container, which is going to change depending on what technology you're using. It could be SMPTE 337 for legacy STI stuff, or 2110-41 for IP, and you send it repeatedly. And there's no standardized repetition method, but once a video frame seems like a sensible thing for us in broadcast. So we've been working in serial ADM for, I think 2019-20 was when we really kicked kind of things off in earnest. We presented it first publicly, proof of concept, at IBC 2019. And since then, we've been working with a lot of partners, looking towards kind of product development. And this kind of opportunity to show some of the fruits of that from our friends at Younger Audio. They kindly have let me share some details and pictures of screenshots of the screens on their Flex AI software platform, which maps onto their kind of products. And it's a combination authoring and monitoring tool, so it can do both those functions. So a kind of typical use case shown here, you'd be authoring something, maybe you've got some audio coming in, you're authoring your serial ADM based on that. And that's going out to a downstream emission encoder, encoding to AC4, for example. And at the same time, you want to kind of monitor what's going on. You want to be doing metadata emulation and checking what the user should be or consumer should be hearing, or creating legacy feeds with renders as well. So here's the kind of authoring screen. So you need to specify what it is that you've got. And starting off, we're not using a full power of ADM here. We need to boil things down, make things kind of quite simple. So the way Younger have done it, they've got this lower and upper channel mode, where you've got the lower is the M&E plus D, and then the upper channel mode is specifying the combination of dialogue tracks. And then some kind of obvious options, and given their history and expertise in loudness control, then you've got options for leveling of sources as they kind of come into the box. So on the monitoring side, you've You've got some basic details about the ADM that you've created or you're receiving over a feed or whatever, like the profile that the ADM is compliant with. You've got the ability to choose the presentation. So the presentation you would expect would map on to consumer choice, like selecting different languages or selecting an audio description and so on. And then you can render those to a particular layout, which is obviously very useful for multi-channel or Atmos feeds. And then the final screen, we've got lots of details about the stream itself, the audio elements that are being carried, and more kind of loudness information. So it's really good to see, after doing proof of concepts and, throwing things together ourselves, Dolby has created tools itself, put it on GitHub and so on, to see that mature and now be able to talk about real products and partners that are in development. And it's not just Younger Audio. There are a number of other organizations listed here that we've been working with on kind of product development. And in the coming months, we'll be able to share more about that and case studies and so on, particularly around the upcoming Olympics. So thinking about serialized ADM then, and what are the use cases for it? What does it do? And how does that fit and map on to the problems that we were kind of looking at earlier on or identified? Well, the good news is, as you would kind of expect, given that serialized ADM is intended to support next generation audio, and the next generation audio is designed to address those problems, sure enough, you're seeing those addressed. But it isn't just that. There's more. As much as I like focusing on the user, there's stuff here for us as professionals. So we've got loudness, logical copies of audio elements that may not seem very useful, but if you want to carry 514 multiple times at different levels because different languages and you're leveling those slightly differently, that can save you a tremendous amount of channels, because you can just send it once and then use metadata to create those copies. So that could save you real money on a kind of contribution link, or be able to give you the chance to support more languages than otherwise possible. So there's stuff here for everyone, and the stuff on the left-hand side, that's what we'd expect to see productized. And then we know there are plans in place in flight for all of that. Some of the stuff, I think the height trims, loudness, that shouldn't be long in coming. The dynamic and binaural, the XR, VR, that's all possible, but expect that to be a much, much further in the future. So, kind of thinking about solutions, and it's been a real kind of chicken and egg problem over the last kind of 4 or 5 years. Kind of obviously the pandemic didn't help, but still it's a real problem of, well, getting the content out there, getting things kicked off, and then being able to present the business case that, okay, well, now we've got content, there's a reason to kind of use it. Thankfully, with some new services launching using the next generation codecs, we hope that kind of cycle will break. But there's been this kind of desire for a killer app that somehow, okay, well, now we've got that, then it's going to move everyone over. And it's just been really elusive. Then the reality is that it's not like that. You talk to everyone individually, and everyone has an aspect of next generation audio that they like or is important to them. Like they want to do multiple language. I have friends in Switzerland, that's really important to them. Or someone else, they want to solve problems with down mixing and automating down mixing and so on. And so it goes. So that in order to solve all these problems for everyone, we need technology that is flexible and does lots of things. And thankfully, the technologies that we have are flexible. So whereas AC3, for example, was built to just do one thing, 5.1 audio primarily, it couldn't really go beyond that without being redesigned. AC4 isn't like that. What's in AC4 today or productized is a subset of what is actually possible, and that's the same case, going to be the case with serial ADM and with 2110. Other folks have talked about the flexibility of that technology. So what does that give us? Well, it means that if we think of a new problem that we need to solve, we don't have to say, well, we need to throw it all away and start again, take another 10 years to develop all these technologies. We should be able to use what we've got today to solve that new problem that we've just, or opportunity that we've just dreamt up. And I've seen that work actually on a call and recently with a few folks, and someone was talking about an alternative music use case where they wanted to replace music because of rights issues, like creating different versions. Well, that's just ideal for serialized ADM to describe these options and provide a way to kind of switch in an emission encoder, produce different services based on those different audio elements. So that's really what it's all about. It's not about solving one thing. It's about flexible technologies coming together and giving us choice and options for the future. So I hope that was interesting.
Well,
thank you all for listening.
That's great, James. That's fantastic. I think the point, again, to bring it back to our discussion, I want to kind of wrap up with also with our panel, is that 2110 comes along and suddenly it brings a lot with it that really matters for moving forward with audio. And one big part of that is channel count, but also suddenly you have 2110-41, so you have metadata transport that's super secure because it's routed by NDI, by NMOS, sorry, by NMOS, in the same way the other essences are. So it is robust and secure. So we now have metadata transport, and then on that metadata transport, the serial ADM is developed, and we've used ADM in film for a long time for file-based stuff. So now we have a serialized ADM, and that's sort of the missing piece. So now we can have these really complex programs. And you talk about alternate music, and that's a thing that we deal with every day, of like there's commercial music and then there's music we have to use on different services. And so managing that becomes a whole lot easier in 2110 because we can have the metadata transport and because we can have more channels. But one of the things I wanted to ask, just coming back to our panel a little bit, is you've just touched on the subject, James, everybody else has, is like, do we need some common understanding if we're going forward? Everything ultimately on Warner Brothers Discovery on Max is going to be Atmos. There's going to be multiple languages. Do we need to sort of tell as audio people, do we need to tell the rest of the industry, hey, we need to standardize on a minimum program audio channel count that's more than 16? Anybody want that? Matt, you're in the middle of it. You're in the middle of it.
Yes. Simple answer. But are we ever going to get there? Probably not. Probably not.
Well, somebody says, let's shoot this game in 4K. And everybody's like, oh, okay, sure. Fine. Like, because it happens at a high level and suddenly like moving heaven and earth to do 4K. And whether that's worth the trouble or not, but even just implementing HDR is work, so, but do audio people say, in order to do what we need to do, we need more channels, and this is a fraction of the bandwidth? Do we need to say, hey, but what worked 20 or 30 years ago. 16 channels seemed like a lot, you know, a generation ago. But do we need to kind of, in order to do the things that we need to do we need to standardize on a better channel count for program? And it's not like we're putting connectors on the back of a box, for Christ's sakes. It's just going into a NIC, and it's literally just software. Have it record more channels, have it play back more channels. Tom?
And an observation across like audio in different markets is that if I put my music hat on and SSL's music production kind of chops, the immersive music there has really gathered some pace from a binaural end user experience that kind of, people like it or not, a lot of music and content is consumed on headphones off a phone, and that binaural as part of music production has become a very major topic in a lot of our music conversations. And James flagged binaural as a future aspect of serial ADM and what that can achieve. So maybe what needs to happen is a multi-channel based approach of production that correctly feeds what a consumer might take on binaural, so that we can plan for our authoring tools and encoding tools to fit those formats. And I don't know that, I know people are experimenting doing things along those lines, but I don't know there's a consensus on the format to do that in, and there's possibly then not a consensus on what you deliver, and that could be objects all the way to the encoder, but there might be an interim channel based in the middle.
Well, certainly we're going to see more objects, even if it's just regular old television and it's having a 514 program with the audio description as an object added to it, so the people who are visually impaired are not hearing just stereo or mono audio. Felix, do you want to answer this question? Put your camera on. Are you up for it?
Hey, Roger, I'm in the car right now in Austria. I'm just following you and chatting.
You can talk.
I can talk. The family is in the car as well, so it could be
good.
Noisy.
No, just talk for a minute.
I just sent you. I mean, in Germany for the Dolby Atmos feed we are producing, we of course we need more than 16 channels, and I'm pretty sure once it sells itself that we will get these channels. I mean, think about 5.1.4 plus surround plus stereo plus radio sound plus a couple of objects, and it might be that we even produce more than just 6 objects. I mean, 6 objects. It might be that you send out your production to your master control room, and they produce 2 streams out of it with whatever 4 objects plus another 6 objects. So I'm pretty sure that the more content we can produce in audio, we will get this. We will get these channels, and we won't stick with just 16 channels.
Well, probably as audio people, you're a little bit better at getting people's attention than a lot of us. But as audio people, maybe we just need to advocate it. You know, even in SDI, the addendum to SDI audio that added, you know, that raised it to 32, then audio people didn't know they could ask for that. And it's sort of the, you know, it's the audio ghetto all over again. You know, we just don't raise our hands and say we need something. You know, everybody gets a bigger and bigger switcher, newer, shinier cameras, and audio people sometimes just don't say, hey, we're gonna need a few more channels. And now that it's 2110, I mean, if Matt can go from 2-channel audio to 514, I think, you know, we can probably go from 16 to 32. So,
yeah,
all right.
I think I think as broadcasters, you know, we can decide on any number we want, but it's all about compatibility with legacy broadcast distribution and all the other things we need to consider along with that. And that's the bit that would be the slow process.
Sure. No, absolutely.
From a transmission point of view.
Was a little bit similar actually to what happened to 5.1. Like it's been around for quite some time, but it was never really adopted. And we had to wait for sound bars and binaural headphones for 5.1.4 or 5.1.6 to break.
Yeah. Well, we're on this sort of sea change. And what's really clear, though, is that we're building these new infrastructures and they're inherently more flexible. But I think we ought to say, okay, well, we need to make sure that we're integrating 2110-41 metadata transport. And maybe we should look at what our program standard is. And when we're about to give EVS $1 million, maybe we should say, hey, can you record more than 16 channels?
Yeah, I wonder whether repository file format, it's not something that I talked about file formats, but there's also evolution that's happening in that. And you've got, you know, the good old OP1A and so on that's been around, but that's going to evolve as well. And the channel counts are going to go up. So I wonder, would that be something that would drive demand? Because, hey, you've got that, you have to have a way to play it out.
Yeah. Yeah. Well, and it's even a problem. I mean, Felix mentioned the music thing, and we talked about the music thing. Even that is sort of like, if you're saving a program, your ESPN, you're saving your major broadcast, you're saving an NFL game, and you're going to have alternate music. And you can't get it in there. Even in 5.1, you don't have room for everything you're trying to save. So anyway, well, this has been great. Thank you, everyone. This has been fantastic. Heather, do you have any last words for us?
Yeah, that was really, really, really good. Really interesting. There's so much we could keep going if we wanted to, but it's nearly tea time over here. So. But yeah, thank you so much to my brilliant speakers and to Lawo for sponsoring this session, and we really appreciate it. And thank you everyone for turning up. This has been brilliant.